Hello friends, myself Nva Assistant Professor, Department of Computer Science, MVP Samaj, Nasik. In this video, we will see how to convert any NFA epsilon into its plain NFA. Means we have to convert it into a normal NFA. For that, first of all, we will try to design transition table, that is, we have to take three states Q0, Q1, Q2 and three inputs that are 0, 1 and epsilon. For Q0 and 0, that is Q0, for 1 it is 5 and for epsilon it is Q1. Next, for Q1 on 0 it is 5, for 1 it is Q1 and for epsilon it is connected to Q2. Next, for Q2, for 0 it is having itself input, then for 1 it is does not have anything, and for epsilon it will not connect to further, so you can take here the Q error or the phi also. So this is the transition table for this NFA epsilon. Now, taking with the help of this transition table, we have to convert this NFA epsilon to NFA. Now we will again here calculate the epsilon closure of states, that is, for Q0 the epsilon closure will be Q0, Q1 and Q2. Next, for Q1 the state connecting with epsilon, that are Q1, Q2, and for Q2 it will itself comes into its epsilon closure. Now we will see how to convert this NFA epsilon to our normal NFA. Means there is some small algorithm that we have to consider for this procedure. That is, what is the procedure? As Q2 is the final state and it is in Q0, so it will be in Q1 and so on for the final states. Now we will find out the delta dash for conversion of a NFA epsilon to without epsilon, means NFA epsilon to NFA. Now first step is what? We have to find the delta dash. What is the delta dash? The delta dash for Q0 on 0 is what? This is the algorithm, that is, we have to take epsilon closure of delta cap of Q0 epsilon on 0. We will see it carefully that what is it? It is epsilon closure of delta cap of Q0 epsilon on 0. What is the delta cap? We have to take the epsilon closure of that state. So what is the epsilon closure of Q0? That is Q0, Q1, Q2. Now the states become epsilon closure of delta of. For this we will take Q0, Q1, Q2 that we had seen before small time to 0. Now we have to take epsilon closure of. We have to apply delta on all these states, means delta of Q0 on 0 union delta of Q1 on 0 union delta of Q2 on 0. Now the delta of Q0 0 Q10 and Q20, we will refer it from the table. That is Q0 on 0 is the Q0, then Q1 on 0 is the phi, and Q2 on 0 is the state Q2 itself. Now we will take the epsilon closure of Q0, Q2. Now Q0 and Q2 are the two states having in its epsilon closure the states, that is, in Q0 epsilon closure there is Q0, Q1, Q2, and in Q2 there is a Q2 state. So taking union of these, we will get at the last Q0, Q1, Q2. As we had applied it for Q0 on 0, we are coming to the output like Q0, Q1, Q2. We have to consider it for all remaining inputs. Means how we have to take the next states like the delta dash of Q0 on 0 is the Q0, Q1, Q2. Now, applying the same mechanism for the remaining inputs means delta of, means delta dash of Q0 on 1, then again delta dash of Q1 on 0, Q1 on 1, and so on. We will get the input outputs like we have to calculate the Q0 on 1, and that is become the states as Q1, Q2, then delta dash of Q1 on 0 is what? We are coming to the output like Q2. Then again calculating for Q1 on 1, we will get Q1, Q2 as output state. Then for delta dash of Q2 on 0 is the Q2, and delta dash of Q2 on 1 become the Q error. So this is the algorithm to find out the states. Means like Nfa to Nfa conversion, as we are getting the new states and again evaluating for that new states like Q1, Q2 again for 0, 1. Here we will not worry about the combination of the states. This is the final. Now how to convert these steps into diagram? First of all, as we will see Q0 having the Q2 as its output state, here again Q2, Q2, Q2. The states which are having the Q2 as its output will all become the final state. So Q0, Q1, Q2 are the final states. Now we have to consider like for Q0 on 0, the output become Q0, Q1, Q2. Means for 0 it have to stop here, again stop for here, and again go to here for 0. Now for 1 it again Q1 and Q2 means 1 and 2. So it is 0, 1. Now for considering Q1 on 0 it is Q2 means here it is 0. Now for Q1 on 1 it is Q1, Q2 means here it has to 1 and 1 again. Now for Q2 on 0 it is Q2, and for Q2 on 1 there is a Q error. As we all know that Nfa does not take care of the error states. It have to design only the limited cases, means only it have to consider the necessary and efficient conditions, not the supporting conditions. So we will not design any flow for the Q error like this. So it will be drop here, and this is the final Nfa epsilon to Nfa, and the procedure to convert any Nfa epsilon to its Nfa.